Okay, so now I'm going to talk about solving equations with fractions. Now, to me, the easiest way to do this is to actually get rid of the fraction. And the way you do that is you look at the denominators and you find a common multiple of all the denominators. Then we're going to multiply both sides by that number. So let's look at these. So we have a 4, a 14, and a 7. Well, we know that 4 times 7 is 28. And we also know that 14 times 2 is 28. So 4, 14, and 7 all have 28 as a common multiple. Or you can say 28 has 4, 7, and 14 as factors. Okay? So 28 is what we're going to choose to multiply both sides of the equation by. Okay? So what you do is you make big parentheses. That 28 means 28 times that. And then you make big parentheses with the 28 here. But if you notice, there's a minus sign there. So this 28 needs to be distributed to both of these. Okay? Over here, we can go ahead and do 4 goes into 28 7 times and get rid of that one. So we're going to bring that down as 7 times x minus 3 equals, this one's going to be 28 times 5 over 14 minus 28 times x plus 5 over 7. Notice I kept my minus sign in front of the 28, and notice that I put the 28 out front. Well, that's the property of community property of multiplication. AB equals BA. So whether 28 is behind it or in front of it, it does not matter. Okay? Okay, so now we can go on to, remember the reason we picked the 28 is all the denominators divide evenly into it, right? So what that's going to do is 14 goes into 28 twice, and 7 goes into 28 4 times. So we're going to have, and I'm going to go ahead and, well, it's okay. I was going to go ahead and distribute that, but I'll just do it the next step. So this is going to be 2 times 5 minus 4 times x plus 5. So now we have a new equation, no fractions. So we're going to simplify both sides by using the distributive property here and here. Going to multiply those. Then we're going to combine like terms on both sides, and then we're going to get our x terms on one side and our numbers on the other. So we get 7x minus 21 equals 10, and this is a minus 4 that gets distributed, so it's a minus 4x minus 20, and we're just going to combine these. So we have 7x minus 21 equals minus 4x minus 10. Okay, 10 minus 20 is a negative 10. Okay, so I'm going to add a 4x. Why am I adding a 4x? Because this is a negative 4x. So for that to go to 0, I'm going to have to add the opposite sign of it. So what I add to this side, I've got to add to this side. And notice I'm putting it under 7x, the like term, not the 21. So they'll scratch out. Now this is going to give me 11x minus 21 equals a negative 10. I'm going to add a 21 to both sides. Why am I picking 21? Because I want that x term to be isolated. I don't want a number with it. So that goes to 0, and I'm left with 11x equals positive 11. Okay? Whatever. When you get down to this point where the x term's isolated and you have a number on the other side, whatever the coefficient of x is what you're going to divide both sides by, because that's going to make it a 1x, or x equals 1. Okay? So what does that mean? X equals 1 means if you went back to the original equation and you got 1 minus 3 over 4 equals 5 over 14 minus 1 plus 5 over 7. Notice I put the x plus 5 in parentheses in front of that minus. Okay, so that's going to end up being a negative 2 over 4 equals 5 over 14. And this 1 plus 5 is 6, so minus 6 over 7. Now in this case, I'm actually going to make this, find an equivalent fraction for 6/7 by multiplying by 2 over 2. So that's going to become minus 12 over 14. So I have a negative 2 over 4. 5 minus 12 is a negative 7 over 14. Now you might say, well, those aren't equivalent, but you have to reduce them, okay? So that reduces to a negative 1/2, and so does that. So you do get a true statement with x equals 1. We call 1 a solution to the equation, so x equals 1 is the solution to the equation. Okay, thank you. Bye-bye.